Good morning. Um, Today we will continue with the inventory control model. So the previous model, that's the simplest model. And in the previous model, we look at the assumptions include quite a few assumptions over here. Demand is known and is a constant demand and also independent demand. We assume the lead time it is known and always constant. And this one, it is receipt of the inventory is instantaneous and complete. So what that means is when you receive, this is the total order received. This is the vertical line. That means the time interval it is 0. Okay, that's the most kind of like this is one of the assumptions you used when you created the basic EOQ model. And the rest of the two, only a variable cost, setup cost, and holding cost. And the last one, stock outs can be avoided completely. We don't have to worry about that. This is the simple kind of like a model. In this model, we get the formula of the basic economic order quantity equals to 2D times S divided by H. Take the square root. D means demand, yearly demand. S means the setup cost or ordering cost. H is the hold cost. But today we are going to talk about another model. This model, we will not use the assumption and receipt is receipt of the order takes no time. And we are going to see this time you have to use some time to receive the order. Part of the inventory cycle during which the production is taking place. That means, okay, and you receive the order taking some place, and then we are going to generate a different model. This is very commonly used in production when production and usage same time are going on, and this model is used when the units are produced and also sold and simultaneously. That's why when you look at the chart over here, and this chart is different from the previous chart. In previous chart, this line, it is the vertical line, it's 0, and it takes no time. But here, we will consider this. It is the you need to use some time to receive the order. So, and in this production order quantity model, here we give some of the define some of the terms used over here. Some of the terms we have seen them before. So, and Q is still the number you are going to determine, to calculate. That's the number of units per order quantity. And H8 is the same. H8 is the holding cost. But we define these terms, P, D, and T. And T, we call this one, it is the length of the production run in days. But P means daily production rate, and D means is usage rate, or you call this as a demand rate, is also per day. So following this formula, we still try to find out what is the intersection point of holding cost and what is intersection point of holding cost and setup cost. For the inventory, annual inventory holding cost, this part is to try to figure out the holding cost. Holding cost, because it's still a linear line, and we use the average inventory level times the holding cost per year per unit. This is exactly same. The physical idea is the same compared with the previous model. And this is the same as well. Maximum inventory level divided by 2, it is the average kind of like inventory level. We use these two logic exactly same as the previous model. But how to calculate the maximum inventory level? This one, we need to consider the usage. So when you consider usage, this is the total production or total parts you produced minus the parts or the total number and minus the used. So it is produced minus used. So T, it is same time period, because P and T, they are all defined as a rate. It's a production rate or it is the usage rate. So, and if you minus the usage from the totally produced, of course, that's the leftover, it is inventory. So PT times together minus DT together, then this is the maximum inventory level. And then go to the next slide. And we know this one, it is maximum inventory level. And then your holding cost equals to average inventory level times holding cost. And average inventory level equals to the maximum level divided by 2. So max level divided by 2. And this maximum inventory level, so here I use some algebra over here to show you how to do that. And so because from this one, from Q equals to, and Q equals to, and to PT, that's over here. Then we can use algebra to find out, oh, T equals to Q divided by P. So, and then I'm going to make this term to substitute T in this original formula. Now your maximum inventory level equals to P times T. But the T, I'm using Q divided by Q divided by P. So, and similarly here it is D times Q divided by P, because these two are all same, they are all T. But from this algebra kind of like equation, I can make some change. So P and P cancel out. So the first one, it is Q. But the second one, you cannot cancel. However, the two terms, we both have Q. I make this Q out. So then this algebra equals to Q times 1 subtract D to P. Now this equation gives us the maximum inventory level. Holding cost equals to maximum and divided by 2 times the holding cost. So if you substitute this number over here, now I get the holding cost. And for the holding cost, and then the next one is to try to find out a setup cost, because your Q star level, it is the intersection point of setup cost equals to holding cost. Now I have the two kind of like terms over here, make them equal. So my Q square and equals to 2ds, this is the same, and as the previous formula, and divided by h, divided by this term. And then your Q star equals to square root of this whole thing. But to distinguish this formula with the previous formula, we add this up over here. This means production order quantity model, you get the optimal like order quantity level. So, and in the previous one, we do not have this part. 1 subtract the D divided by Q, but this one, we add this part. So this is the first in-class practice. And please open your in-class practice 7 at e-learning. That's the Word file. I do want you to use the equation editor, and because this example does not use any kind of like large volume of data. At this moment, you don't need to use Excel. Just please open the and Word file. So open this up. And I already gave the note over here. This is the production order quantity. And the formula we are going to use, it is insert a formula, equation. So this one, it is P. It is here is the Q, but you need to add the P sub over here. And on the top, it is the star. That means optimal. Okay. And then equals to the square root. This is the fraction template. And you see 2ds and divided by h. And then it is 1 subtract. Here it is d divided by p. Okay, this is the formula we are going to use. Look at over here. Here's Nathan's forecast for its wire wheels is 1,000 units per year. Here it means demand. So yearly demand. And then with average daily rate, demand rate. So this is 4 units, it is D. Demand rate, it is D over here, small d. And however, the production process is most efficient at 8 units per day. So here 8, it is P. It's production, it is P. So this one we can make the mark as this is a P level, small p. And this is a company and it produces 8 per day but uses only 4 per day. And the company wants to solve the optimum number of units per order. And given the holding cost is 0.5 and the setup cost it is 10, and also told us that here the company, they have 250 days per year. So, and with the giving information, we just simply plug in all those numbers to get the optimal quantity level. So here it is 2 times 1,000. Here it is the yearly demand. S is the setup cost. So ordering cost, it is 10. And then holding cost is 0.5 times and 1 subtract. Here it is usage level, it is 4. And the production level is 8. So now we got, and the calculation, this one shows it is 80,000. So equals to, and 282.8. Or you can say it is about 283 and units. 283 units. That's the first one. It is simply, and apply this production order quantity formula. So we set up the model, we use the model. And the second practice over here, we have more questions we need to answer. So this is the race car motor, and it's kind of like electronics, they produce motors. Race race 1 motors produce a certain component at the rate of 300 per day in the facility. It uses these subcomponents at another facility at the rate of this is per year. So they give you the yearly demand, and they also give, say, this is 250 days, and then you need to figure out what is the daily usage. That's the small. So this information will provide you, and capital D, that's the yearly demand, and also the small d and the daily usage. So we are given the holding cost and the ordering cost. Now, what is the economic production order quantity? The first one, we use the same formula. So I'm going to copy this formula right away. So copy this formula over here. And then equals to, just plug in the different numbers. So it is 2 and times 12500. That's the yearly demand. And times the another one, it is S. S, it is the setup cost or ordering cost. This one, it is 30. So divided by H. H is the holding cost per item per year. So times 1 subtract. So, and this one, we have the production like rate already. So it's 300. And probably I need to add something information and in the beginning. So I will add this one, insert equation to find out. So insert small d equals to, and the yearly demand rate divided by how many days of the production. So this one gives us the result of what is the usage rate. So this is the usage units per day. So after you insert this part in, oh, I can use this number in my second equation. Now, and we can calculate the second, like the optimal production quantity, the order quantity, 671 units. That's the first one. And the second question is, how many production runs will be made in each year? So the production, and how many of production runs per year? And so this is because it is per year, I'm thinking this is the number of production run per year equals to and 12500 and divided by 671 and equals to. So let's calculate this number is equals to 12500 divided by 6 and 71. So this one, 186, it is per year. Per year. Then what is the maximum and inventory and level? So this one, we need to go back to see what is the maximum inventory level. Maximum inventory level equals to and capital Q times 1 subtract D and H, because this is your maximum inventory level. So, and back to over here, I can insert equation and maximum inventory level. And this one equals to your capital Q and 1 subtract D divided by and P level. And I'm here. I should use specifically. This is the maximum optimum level. Here it is P. Here it is, and here is the star, and here it is P. And then we can substitute 67.1 into this formula, and times 1 subtract D. It is the production level. So D, it is the usage level, demand level. Okay, here it is 50. And 300 is the production level. So, and this result, it is the 559. Here it is the units. Here, that's the maximum inventory level. And this equation, or this question asks us to go back to look at your derivation process. How do you derive this? How do you figure out this production order quantity model? In this production order quantity model, we need to define what is the maximum inventory level. So this maximum inventory level, and we use Q and use D and use P can be figured out by using this. Now, this equation or this question asks us to review what is the maximum inventory level when you try to figure out this formula. Okay, and then the next one similar. So what is the annual cost of ordering and holding inventory? So this one, it is the annual cost of inventory. So this include, I would include the holding cost plus the setup cost. So I included the two components. And for the holding cost, it is per unit per year. So it is what is the total cost of 18 point? So equals to your average and inventory level. So average inventory level equals to maximum inventory level divided by 2, and times your holding cost. So times the holding cost. Oh, right. Divide. Times the holding cost plus it is how many kind of like how many runs. So this it is. Let's see. Oh, my calculation, I have more zeros. It's 18.6. So we need to change this number. Here it is 18.6. It's not 186. So it is every year you need 18.6 runs, and then that means you need to count all of the ordering cost. It is setup cost, and times and the runs. So I just write over here, and then put the formula here equals to maximum level 559 divided by 2 and plus times the holding cost. The holding cost is $2 and plus how many runs? 18.6 runs, and then the ordering cost is 30. So the yearly total cost of ordering holding inventory cost equals to $111 and $7.9. In my calculation, this part, I'm trying to let you know what is included in this total cost, total inventory cost. And the first part, this one, it is the holding cost. And the second part is the setup cost. And the cost for the holding cost always is the average inventory level, and that times the single unit holding cost. And the average level always equals to the maximum level divided by 2. That's why you see in the calculation is 559 divided by 2. And the second part, it is in 1 year, because of the demand, it is 12500 units. And then based upon the Q star, we need to make 18.6 runs. That's why we have the calculation over here. I think the first question is just to let you to be familiar with the production order quantity formula. The second problem gives you more understanding, and in this formula, what is the individual components you included, how you and help you to retain the information, how you understand the model. Okay. And that's the two kind of like POQ practice. The next one, I'm going to talk about one very kind of like commonly seen like industrial scenario. That's the discount. How do you use discount? Take advantage of the discount to hold your inventory, to keep your inventory level. So what is a discount? Discount means, okay, the reduced prices are often available, but is only give you the condition you order a large quantity. And if you order small quantity, they won't give you the discount. So, and the trade-off of this model is, we need to figure out what is the optimum level we can take advantage of this reduce the price, but we don't want to order too much. Because if you order in a very high, and the quantity very high, it's going to increase the total inventory cost. That's the reason. So, and there's a model of the total annual cost model. This model, we have three kind of like items. One, it is the setup cost. Setup cost, if you order the Q, it is bigger, and then this number will be small, and it's going to reduce the cost of setup cost, obviously. And if you use the P level, price level, uses a discount price, and it's probably is going to drop this second portion at also. This is a holding cost. So setup cost will reduce and the holding cost will reduce. However, the product cost, if you order in big number, then this part will increase. And then, even though you purchase with a reduced price, but you order so many, and then it's going to drive your total annual cost goes up. So our kind of goal is to try to find out the minimum and the point we can take advantage of reduce the price, but also we want to keep the total annual cost to be minimum. So in this equation, we still see D, Q, S, and Q it is order quantity, and D it is annual demand. S still it is the setup cost, but here this part P and I, P it is the price per unit. I it is the holding cost per unit per year, but it is given as the percentage of the price. So they didn't say the holding cost is $2 per unit per year. Instead, they said, okay, the holding cost is a percent of the original or the unit price. And go back to this example, okay? And we understand our goal is to try to find out the minimum total inventory cost. That's the three kind of portions: the holding cost, the setup cost, and the product cost. We want to make the three to be the lowest point. When you look at this quantity discount schedule, they found apart if you order and from 0 to 119, then you have to pay the original price, $100. But if you order something larger than 119, if your order is in this range, you are going to pay the reduced price. It's $98 per dollar. If you order even more, lower, bigger than 1,500, then you can take advantage of the even lower price. This red number over here, 120 and 1,500, we call them price break quantity. Price break quantity means, okay, you reach the minimum level you can use the discounted price. So we give them a special term. This is called price break quantity. So how can we do that? For the quantity discount model, we always follow the two steps. If I do not explain the two steps, I think students, when they just read the book, probably they do not understand how to calculate the total quality, total and inventory cost. First, we want to start with the lowest possible purchase price. Calculate the Q star. So what's that mean? So for this one, and 98, and so here it is. The example is we use the lowest price, 96. We can calculate a Q star, and then to see if we can find out the first feasible EOQ, and then try it. This is the possible best order quantity, and use this formula. and then calculate for each of the price. 96, you try to find out the Q star. For 98, you try to find out Q star. And then you compare all of the total cost. Calculate the total. We try to find out the total annual cost for each possible order quantity, determine which one will give you the lowest cost. I'm going to use an example to show you and the two steps. How do we find out the first feasible order quantity, and how do you calculate the total annual cost? So this is the example, okay? And this is from our textbook. And this one, they said, okay, and if your order quantity reach to this level, 275, you can use 98 in the unit price. If your order quantity it is bigger than and larger than 1500, then you can use the reduced price. So this is the electronics stocks toy remote control drones. Recently, the store has been offered a quantity discount schedule like this. And also we are given the setup cost is 200 per order. The annual demand, it is 5,200 units. 5,200 units per year. And the inventory carrying holding cost as a percentage of the cost. This is 28%. And let you find out what order quantity will minimize the total inventory cost. So, and the first one, we use the lowest price. Lowest price is 96 to find your Q star. This Q star with the 2 and okay, here it is Q level and H level and I times P, this is the S. We find that the units is 278. And because we are using 96, 96 is only available this price when you order more than 1,500, right? So because this 275, actually this you cannot really get this price. And because your calculated Q, it is smaller than the break and price break quantity. So this EOQ is not possible because you have to order minimum 1,500 to get the discount price. How about we go with 98? So the second step, calculate another unit price to figure out what is the Q level. And in this one, we found, okay, this is 275. This one, it is feasible for 98 price because look at the schedule over here. If you reach this level, and you can take advantage of this 98 price. Yes, we already reached this level, that's it's okay. But how do you calculate the annual, ordering cost, the annual holding cost, the annual product cost? That's the part I wanted to show you. This one you need to use Excel, okay? So go and open your Excel. Bless you. So, and the first tool, And use the equation and find out all of these Q stars. So it is 2 times 5200 and times 200. This is 200, it is setup cost, divided by your holding cost, 0.28 times 96. So this is trying to find out a Q star. And this one, it is 278. 278 units, you cannot use the 86. And the next one we want to calculate is to 5200 times 20, 200, and divided by and 0.28, and then it is 9 times 98. So this one we got is 275. Now the next step, I'm going to use the two kind of like price level to calculate the total annual cost. And because this number actually is a dummy number, 278, you cannot really use this number because in order to reach 96 price, you have to minimum order 1500. That's why for this, if you use the 1500 as your order quantity, and then you can compare your total price. So the first one, this one equals to, if we order as 1500, and then this equals to yearly demand divided by yearly demand divided by Q. This Q equals to 1.5, actually is this number. And then times what? Times your setup cost. Setup cost in this case, it is 200. So that's why you got this number is 9693. And then what is the holding cost? Holding cost equals to Q level. Q, you must order 1500 and then divided by 2. And times I equals to 0.25, and times your unit price, 96. So this one we got is 20160. And what is the product cost? The product cost equals to, and that's the, and product cost, it is P, and the P level, it is Q, this is yearly, and times, and what is the unit price? That's not unit price. So, oh, I forgot. Then the 3 added together, so equals to sum of the 3. Annual order and cost, and annual holding cost, annual product cost. That's the total cost if you order 1500, and by taking advantage of the discount price, 96. And because 275, this order quantity, when you calculate this order quantity, you use 98. Now, so 275, it is feasible. So this one, it is feasible. This one is not feasible. It is feasible. order this is a feasible EOQ number, but here 1500 is not. You 278 it is the one. Okay, we calculate, but you cannot use this number to calculate because minimum you have to order 1500. For this one, the ordering cost equals to 5200 divided by the order quantity and times S equals to 200. And the annual holding cost equals to Q here divided by 2 and times 0.28 and times price. And the annual cost equals to this unit price times and 5200. So, and then your sum of the three, that's the total annual inventory cost. It is 517155. And obviously, this is your answer. So, because, and 517 and 155, it is less than, and 520053. And we will choose to order and 275. We will choose 70 as order quantity. So, and then in this case, your 1500, you have to minimum order this, but you compare, you find out this is the smallest total cost, you will go back and to select the 98 price instead of using the 96 as a unit price. And textbook only give us one example like this. But when I read by myself, it took me quite a while to figure out how to calculate this cost. How do you understand the Q star level? Why this Q star? Some of the Q star level is easy, is okay to use. Some of the Q star is not okay to use. So this Q star doesn't help. Okay.
Can you go back through the D13?
What 13? E?
D13.
D13. Yeah. D is Q. Q, it is order quantity over here. Actually, I gave the formula, D divided by Q times S. So this is D. So we can copy this to our Word file, and when you submit this, actually, I gave you this result, but probably you don't know how you get this result, right? Did you open your Word file? You have this table, right? But you don't know how to get this table. Now I tell you, that's the process, how you get this table. And then maybe we add this sentence over here because and the next practice, similar, discount model. And we are going to repeat this. I'm not sure whether you can figure it out by yourself or not. If you can't, you can follow me. So I will go back to my Excel, my PowerPoint, let you see. Here is the essential idea of the discount model in this example. So if you use the 1,500 as the discount price, your like a total cost will be this green line. And if you use 120 to 100 of 1,500, now this total total inventory cost will be this red line, and this will be the blue line. And because look at this in this range, and this is the lowest point. And your calculation showed, okay, and because at 520053, you get this, it is choosing the 1,500, but with the 250 somewhere over here, you get is 515,000. That's why this is the lowest point, and you cannot take advantage of the discount price of 96. You only can use as 98. This is another example. So here is a discount store stocks toy race cars. Recently, the store has been given a quantity discount schedule for this table, and they also give us is the normal cost for the toy cars. Toy race cars is $5 each, and if you order between 1,000 to 1,999 units, the price is 4.8. Order larger than 2,000 will be 4.75. And also given the 49 as ordering cost, annual demand it is 5,000. The holding cost is 20% of the price. So, and I want you to go back to this table, and you can use this table to calculate your Q star. So this one, the Q star, use the lowest price first. It's 5,000 and times, and 49, it is 49, it is the hold cost. Is S. Here should be S. Setup cost and S. This is S as well. QS divided by IP. S. So IP is 0.5, and the unit price it is 4.75. That's the first one we want to calculate. So this is 718 units. And this 718 units not reaching to 2,000 yet. So this one is not feasible and price break quantity. How about the second one? Two 5000 and times 49 and divided by 0.2 times the price level, it is 4.8, and this one it is 714. The last one, it is 5,000 and times 49 divided by 0.2 times the price. It is original price is 5.0. So here is 49, not 19. And this unit, it is 7 700. Okay, so for 700, and you use $5 per piece as your unit price. And for 4.8, that's the first discount. And the discount, it is you need to be at least 1,000. So this 714 doesn't work. So it's not a feasible like order quantity. Similarly, 718 and is not a feasible order quantity. So now we want to calculate the total cost if you order 2,000, or if you order 1,000 as an order, or you use 500, use like 700 as your order to find out what is the total cost. So this time I'm going to start from the top to the bottom. And annual product and cost equals to product cost. It is unit price times this. And annual ordering cost, this one equals to how many orders? Okay. So here it is yearly demand. It is 5,000 divided by Q. This Q, it is 700, and then times the S setup. The setup cost is 49. And the holding inventory cost equals to Q level divided by 2 and times, and the percentage is 0.2, and the times the unit price. So the total should be sum of the three. Oh, I think this one is wrong. So you should times, it is D price times the yearly demand level. Yearly demand, it is 5,000. So after we set up the first row, we can, I think we can just drag the formula here and drag the formula. Yes, that's correct. And from this comparison, we found out that this one is the smallest number. So, and we can use the discount price of 4.8. Even though you order a little bit more, and then it's going to work, okay, because they give you a total inventory, annual inventory cost. So this one is the smallest number. So this one is the smallest number. And then we can take advantage of the unit price. So, and I already gave you this result from my Excel, but the process I just showed to you, just want to tell you how I came up with these numbers, how I calculate, and what is the fundamental ideas to compare the total annual inventory cost. F what? F10. Okay. Here, Q divided by 2 times I times P. Price. Okay. Then I would just go back to this Word file, say, okay, and because, and 24725 is the lowest total inventory cost. It is worth to order 1,000 units per purchase. How about this? Purchase per order to take advantage of the discount price. So then you save your file, and then you submit it to e-learning. And I hope you all, because the Word file, and I think you need to use, because I'm demonstrating the Word equation editor, so I hope you all do the same equation editor, style and everything with me together. And you have this already in your kind of like practice sheet. That's the result I gave it to you. But I still, I want you to follow it with me together to do this practice, Excel practice. The Excel practice, if you follow it with me together, you understand how I calculated the total inventory price. But, and hope you just finish all of the 3 problems. 1, 2, 3, actually 4 problems I'm submitted to e-learning. Okay? And so I stop